heat is required to warm 1.9 kilograms of sand from 30 degrees Celsius to 100 degrees Celsius if the heat capacity of sand is 0.84. So we're just solving for what? The Q. Q equals CS multiplied by mass times delta T. Now, can we just plug in everything without having to do any conversions? Well, no. C right here, it's grams, and C right here, it's kilograms. With that said, this needs to be converted to grams. So I don't even have to convert that. I'll put that inside the formula. The specific heat was given, which was 0.84. The mass, what we have to convert, is 1.9 times 10 to the 3 multiplied by 100 minus 30. Now, some people may say we have to convert Celsius to Kelvin. We do not, because, let's see, Celsius would be, if we did convert this to Celsius, would be plus 273 and plus 273. So that would be 373, and this would be 303. Say if we want to do T final, T initial, we do 373 minus 303, which equals 30. If you notice that this is the same exact value from just doing 100 minus 30, and this equals 70. Oh, I apologize, it's supposed to be 70. Both values equal 70. So it doesn't matter if you don't have to convert it from Celsius to Kelvin. Anywho, going back down to here, if you did 0.84 multiplied by 1.9 e to the 3 multiplied by 70, you should get a value of this. Q equals 111,720. And that is the answer. Well, if you want to simplify, you can go Q equals 1.1 times 10 to the 5 joules. 6.17. I'm only going to do one of these on 6.7 because there's like 4 of them and they're all the same exact process. But what I will do is I'm going to give you the specific key for each and every single one in case you couldn't find that in your book. The first one is we're dealing with gold, AU, which has a specific heat of 0.128. Now we deal with silver, which has a specific heat of 0.235. Then we deal with aluminum, which has a specific heat of 0.903. Alright, so let's solve this out. We have, suppose that 25 grams of each substance is initially at 25 degrees Celsius. What is the final temperature of gold upon absorbing? The final temperature. So what's this formula look like we're going to use? The same exact one that we've been using. Q equals mass multiplied by specific heat multiplied by delta T. Now, if I were you, I would rewrite it like this. Mass times specific heat times TF minus T initial. Since it says we're going to have to solve for TF. Alright, so let's just, do the algebra. We want to solve for the final temperature, so I'm just going to get everything to one side. I'm going to get Q. That doesn't look like one, does it? We're going to get Q divided by mass times specific heat plus 25 equals TF. Does this look right? Yep, we got mass specific heat on one side, then we added the T initial onto the other side. So the TF equals Q divided by M times CS. Now let's plug in what we know and we don't know. So we have Q, which equals, up here, 2.25 kilojoules of heat. But we got to be careful. The specific heat I gave you was in joules, not kilojoules. So we're going to have to convert 2.25. No big deal. 2.25 times 10 to the 3 divided by mass, 25, multiplied by 0.128, the specific heat of gold, plus 25. Now, when you do this out in your calculator, what do you guys get? I roughly got a value of 730. 730. So 730. So TF equals 730 joules. That is the answer. Now this problem has you do silver, aluminum, and water. So this is going to be the same exact process. You're going to put the problem out, you're going to solve for TF. So you get Q divided by mass times specific heat, then you're going to add this 20, the T initial all over, and then, which is 25 because it was given up there. And then you'll get the TF. So once you do that, you'll find them all, and it's not too bad. If you guys need any help, just get back to me during class or give me an email and I can make another video for you if you would like. We have one more to do. During a breath, the average human lung expands by about 0.5 liter. If this expansion occurs against an external expression of 1.0 atm, how much work in joules is done? Alright, so what formula are we going to use, and what does this even mean? If you look back at the first question, we were dealing with energy equals Q plus W. Q stood for what? Q stood for heat, and W stood for work. Now, do we have to use this entire problem throughout this this entire equation to this entire problem? No, because it's only asking us the how much work is done in joules. So let's just deal with the work. So work, as earlier we stated, equals minus pressure multiplied by delta V. Perfect. So we know everything, don't we? We just don't know how to put it into joules. That's what the problem initially is. So work equals the pressure, which is given of 1.0 atm. Now, it was a negative. I just put the negative in there because it was in the formula. Multiplied by the change in volume. What was the change in volume? Initially, it was 0, and it says it expanded to 0.5. So 0.5 is the final minus 0 liters. What does this value equal? Just simply 0 minus 0.5 atm L. So as earlier we learned that 1 atm per liter, or atm L liter, equals 0.101 kilojoules. So that means it equals 101 joules, because the question wants the answer to be in joules. So now, just one more simple calculation and we're done. We got minus 0.5 multiplied by 101. What's this equal? Roughly minus 5.1 joules. Now some of you may be saying, why is it a negative value? Does that make any sense? It makes complete sense. So the system is going to be the lungs. And it says that since we're finding the work, it's right here, it says how much work is done during the expansion. The lung is doing the work. And from earlier we know if the system is doing the work, it's going to be represented with a negative value, which is why this is a negative value.